In the first part of lesson 2, we saw how to switch between factored form and standard form. Going from the factored form of a quadratic to standard form involved that binomial multiplication, where we see the double distribution. Now we're going to look at going the other direction, going from standard form backwards to factored form. It's important for us to remember that standard form is the trinomial. It's ax squared plus bx plus c. Last unit, we saw how we could factor a trinomial using the product sum puzzle. We wanted our product to be c and our sum to be b. So we're looking for a pair of numbers that multiplies to c and adds to b. It's probably easier with some specific numbers. So let's take a look at some examples. Here we have y equals x squared minus 9x plus 8. So we're trying to multiply to get a positive 8, and we're trying to add to get a negative 9. We want to pay attention to that sign there because that will be one of the trickier parts about these types of problems is making sure that we get the signs correct. If we look at the list of numbers that could multiply to give us 8, we can always build this list using a calculator and just doing division over and over. So if I do 8 divided by 1, I get 8. That means 1 and 8 both work. If I do 8 divided by 2, it's going to give me 4. So 2 and 4 could give me 8. The only thing left to try at this point is 3, which doesn't work. And so we can add these together. 1 plus 8 gives us 9. 2 plus 4 gives us 6. This looks close, this 9 here, but we want it to be a negative 9. We want to remember when we look at these factors of 8 that a negative 1 and a negative 8 could still multiply to give us a positive 8. But when we combine those, we get the negative 9 that we're looking for, not the positive 9. So when we write our factors out here, we'll say y equals, just like with the binomial multiplication, we don't change the y, we only care about the trinomial piece here, but we are going to rewrite that. We're going for factored form, so we'll have two sets of parentheses. They'll both have a binomial. One of them will say x minus 1. The others will say x minus 8. So now we've gone from standard form to factored form. Let's take a look at another example. Here we have y equals x squared plus 3x minus 40. We want to multiply to get a negative 40. We're going to add to get a positive 3. What numbers could we use to get, there we go. What numbers could we use to get a negative 40? Whenever we build a list with a negative product, we need to remember that there's two combinations. Let's just do 40 divided by 1, and we get 40. Can't find a good way to work with this. So we have 1 and negative 40, as well as negative 1 and positive 40. We don't need to worry about using those signs in our calculator. We just remember when we build our list that we write each one as a positive and then a negative. If I do 40 divided by 2, I get 20. So 2 and negative 20, negative 2 and positive 20. Now I can do 40 divided by 3. Because I get a decimal, this answer doesn't work. So let's do 40 divided by 4. Like I said before, we just keep counting up. Since our answer was 10, we could do 4 and negative 10. Or again, switch those signs with a negative 4 and a positive 10. Numbers are getting pretty close together. We're probably just about to the end of our list. Let's do 40 divided by 5. We get 8. So 5 and negative 8. And then we switch the sign, negative 5, positive 8. If we try our last few numbers, we do have 6 and 7 we could try. 40 divided by 6 gives us a decimal. 40 divided by 7 gets us a decimal. We've completely built our list. So now we've done all this work finding our factors. Which factors of 40, what multiplies to 40 and adds to a positive 3? When I look at a pair of numbers here, like 1 and 40 and -1 and positive 40, they're both going to get the same number. This is going to be a -39, whereas this is a positive 39. So I'm not going to check every single one of these. Let's say I do -2 and positive 20, that's 18. We're looking for a 3. 4 and, sorry, let's do -4 and positive 10. Well, that's going to be a 6. Well, we're still not getting the 3 we're looking for. It doesn't matter what the sign's there. Let's do 5 and -8. Well, this gets us a -3. Okay, so we're close. We wanted a positive 3, though. So we would switch those signs. Our factors are -5 and 8. So now what we need to do is we need to rewrite our equation. It's going to still say y equals. That is still a part of our equation. And we're going to factor this trinomial here. We'll have 2 parentheses. Both of them have an x. One of them will say -5, and the other will say +8, using those 2 factors from down below. Since we've practiced this skill before, I'll leave it to you all to try number 3 on your own. And before we wrap up this lesson, I want to also talk about some special cases down below. Actually, I have a check in there. Let's do this one real quick then. All right, so factors of -10. I'm not going to build, well, I'm going to build the full list here. We could do -1 and positive 10. Or we could switch those signs. We could do 2 and -5 or -2 and positive 5. That's the full list here. If I add this together, I get a 9, so it's neither of those. If I do 2 plus a -5, I get -3. So there's the pair we're looking for. Y equals, we got 2 parentheses, x plus 2, x minus 5. You all can do the check-in on your own. That'll be some good review, some good practice with this product sum puzzle. In the meantime, let's look at special cases. So the following special cases could be really useful for you. They may show up on something like an EOC, which has been canceled this year, but it's still an important set of rules to know. In each of these, the factored form is going to use the same number in both factors. That number is going to be represented by a. So in this first one, what we're really saying is x plus a times x plus a, because it has that square. That gives you a pattern where x is squared and a is squared, because they multiply with themselves at some point. But there's also going to be 2 ax terms from a times x and x times a. So you get 2. If there was a minus sign of the parentheses, you would still get the same pattern, but now the middle term has a negative. And then this last one is actually super, I think it's kind of a super fun rule. We have x plus a and x minus a. And so what happens when we factor that out is it gets rid of that term in the middle. There's nothing in the middle. The positive and the negative cancel each other out. We're actually going to start with that rule down here on number 1. We're going to take a look at this one first. I just think it's that important for us. So here our a value is 4. That may help us if we try to use this rule directly. If we go about this the way we always have, we can still use our double distribution. X times x gets you x squared minus 4x plus 4x. So there are those 2 x's that are going to cancel. And then if we do 4 times -4, we get -16. When we combine this, make sure this is still an equation, we get y equals x squared plus 0x minus 16, because we did -4 plus 4. We don't really need to write that 0x in our solution, so we can go a step further and say y equals x squared minus 16. Well, if we look back at this rule up here, it does say we would have x squared minus a squared. Well, if we do 4 squared, we get 16. This rule works when we plug in actual numbers. We can see that from what we've just checked here. Where this matters more is the reverse case, where you're factoring out the expression. If you look at number 2 here, that looks a lot like our answer that we got for number 1. We have an x squared, and we have a perfect square. You can always use that perfect square table. I should probably get that back to you guys. But if we look there, 49 is a perfect square. If a squared is 49, because that's what we'd have from our rule up there, we're replacing the a squared portion. We can solve this by taking the square root of both sides. That's how we solve an x squared expression. We get a equals 7. You would need to do this step in order to factor out that 49, or you could use your perfect squares table. Otherwise, you may have a hard time coming with our solution. It is going to be factored. It does have 2 parentheses above. They both have an x. One adds that a value. The other subtracts that a value. This pattern is one that you can expect to see a lot in Algebra 2 and other more advanced algebra. You could still factor this out if you knew that the middle term was 0, but that's a pretty hard thing to piece together on your own. Let's take a look at number 3. We've seen problems like this before. I've already asked you to multiply these once, and the secret was that we have a square here. We're going to go ahead and rewrite this x minus 6, x minus 6. It's multiplied by itself. From here, we can do our double distribution. X times x is x squared. X times 6 is negative 6x. Then we do it again, negative 6x plus 36, because we're doing a negative 6 times a negative 6. Those signs will change. We'll combine like terms here in the middle. And so we get y equals x squared minus 12x plus 36. If we look back at our rule, in the middle column here, this holds up. If we look at this part right here and a squared, our a equals negative 6 up here at the top. A squared is going to be a positive 36. And if we look at this 2a part right here, 2 times a would be 2 times 6. Well, 2 times negative 6, it would get us a negative 12. We don't have to use these patterns here at the top, but these patterns do appear. And so if we know that these are things that exist, we can work with them and be prepared to tackle those kinds of problems. I will see you all in the Lesson 3 video. Be sure to complete the practice and the progress check. Contact me if you have any questions.